My name is Hannah Murphy from DS24 at the Data School, and today's video will be all about Snowflake, looking at the benefits of using Snowflake over other non-cloud-based servers, as well as a brief overview of the interface and some other simple use cases. So first things first, what is Snowflake? Snowflake is primarily a cloud-based data warehouse, although it can be used as a data lake if required. So when we say a data warehouse, what do we mean by this? A data warehouse is a collection of databases storing lots of different types of data from various sources. This becomes an almost library of data, and each person can own multiple warehouses, so you're not restricted to storing all of your data in one warehouse. A database is an organized collection of tables that contain rows and columns of structured data. This is where it differs from a data lake. A data lake is a repository where structured and unstructured data is stored before it's brought into the data warehouse. It can be considered an almost dumping ground of data. So when we say Snowflake can be considered to be both a data lake or a data warehouse, it means that both structured and unstructured data can be uploaded and accessed. It just depends on how you want to use it. So when we talk about the cloud, most people will probably think of the Apple iCloud, which is one of the more commonly used cloud services. However, there are actually multiple platforms, cloud-based platforms, to choose from. And of those, Snowflake supports 3. AWS, otherwise known as Amazon Web Services, Microsoft Azure, or the Google Cloud Platform, otherwise known as GCP. When you sign up for Snowflake, you have to choose what cloud platform you want to deploy Snowflake on. However, you're not limited to this. Snowflake is also cloud agnostic, which means that data can be duplicated and or spread across multiple platforms and regions. And so a company can have multiple Snowflake accounts across multiple platforms and have multiple regions. And so if one crashes, their data is still protected and accessible, but also by having multiple regions, employees can access data from all over the world with minimal delays. So what are the benefits of using Snowflake and why should we use it? Snowflake is built specifically for cloud use, and so there's no hardware or software to install, configure, or manage. The nature of the cloud means that it overcomes some of the problems that can be common in other hardware-based data warehouses. So a big issue that a lot of people encounter is performance and speed. If you want to load data faster or run a high number of queries, you can scale up or out your virtual warehouse to accommodate these requests. So what do we mean by scaling up and out? This really depends on what you need Snowflake for. Scaling up is the process of increasing the size of your warehouse by upgrading the RAMs and therefore creating a more powerful single server, which allows you to run large queries faster. In comparison, they're scaling out. So this is the process of increasing the number of machines. This allows you to divide the work across multiple resources and carry out multiple tasks or run multiple queries at the same time across these multiple machines. Furthermore, the flexibility of Snowflake means that you can increase or decrease the size of your warehouse based on your requirements at that time and only pay for the time that you have used. Snowflake also makes your data accessible. You can store your data in a number of availability zones using AWS, Azure, or GCP. Whilst these servers can be held in a physical warehouse, you do not need to be in close proximity to store and access your data and can use any of the availability zones regardless of your location. However, it is also important to note that deploying data from the other side of the world will cause delays, and so it makes sense to choose the zone closest to you. Often companies will duplicate their data and store it across multiple zones to ensure that it can be accessed quickly. Snowflake's data sharing capability allows companies to share tables to users outside of the account. So for example, a supermarket sharing sales to their suppliers. This can be done using CSV files manually, but that often led to a duplication of data and a lot of wasted labor time. Sharing a limited view of live transactional data eliminates these human errors and is fairly unique to Snowflake. In this example, a supermarket sharing this live transactional data with their suppliers ensures that the supply of a particular product is always accurate and as close to their sales at the time, although nothing is completely foolproof. Finally, Snowflake works around the concept of high availability. This aims to ensure an agreed level of operational performance, otherwise known as the uptime requirement, for a higher than average period of time. The aim of this is to prevent system crashes and the loss of data. System crashes can also be referred to as downtime. This is calculated on the basis of the nines. So this table here better demonstrates what's meant by the nines. The idea is to have as many nines as possible to minimize the amount of downtime. So over here we can see that 1 9 would equate to just over a month of downtime per year and about close to 3 hours a day as well. So this isn't the best performance and probably wouldn't really be wanted by most large companies who want to optimize performance all the way through the year. So ideally we want as many nines as possible, but it's hard to design a server to that specification whilst also keeping it accessible and at low cost. Snowflake is designed in a way to give you the maximum number of nines whilst remaining cost effective. So when we're thinking about Snowflake, it's also important to understand what ELT and ETL mean. So the E is extraction. This is getting your data out of a source system. For example, a transactional database, a CRM system, such as Salesforce if you're familiar with it, or website logs and activity. Transformation is changing your data. So this is blending, shaping, trimming your data to find valuable insights. This is where filters and aggregations come in, and it's where you will also do calculations. Finally, there's load, which is the L, and that is essentially loading to your database or into Tableau or any other software. So this order, ETL, was traditionally used by older systems due to limited capability and processing power. However, Snowflake favors ELT, which allows you to load your data into the cloud at minimal cost and do your transformations there. We'll come to this later. So now let's take a look at the Snowflake interface. So this is what you'll see when you first open Snowflake. Up here, you'll have your account with a number that identifies it, your organization, so in this case the information lab, your edition, so that is how much you're paying for Snowflake, your cloud-based service, and also your region. Up here you can also take a look at your role. So your role is linked to your permissions and it limits the data that you can view and edit. Up here we also have the help page, which is where you can look at documentation, visit the community, and download drivers and extra software that may be needed to best use Snowflake. Then over on this side up here you've got your databases, your shares, the data marketplace where you can import more data, your warehouses, and your worksheets. So your worksheets will also be shown here as tabs, and this is where you'll write your SQL queries. Think of each one as a sheet in either Excel or Tableau. So when I say SQL, I mean structured query language. So this is a computer language that allows you to transform your data within Snowflake. It's also present in Tableau and most servers. So over here we can see our databases. Ideally, you would have a different database for each data source that's coming into the data warehouse. For each database, you can set your permissions either by person or by role. In each database, you'll find a series of schema. So right here, there's the bookshop, and down here. This is a collection of tables that contain data related to each other. A database is a collection of schema. Inside the schema, there are also the tables. So Snowflake offers 3 types of tables: temporary, transient, and permanent. A temporary table only exists within the session in which they are created, and exist only for the remainder of that session. They are not visible to other users or in other sessions. Once the session ends, data is stored in the table and purged completely from the system, and therefore it's not recoverable either by the user who created the table or by Snowflake. Transient tables exist until explicitly dropped and are available to all users with the appropriate privileges. These are specifically designed for transitory data that needs to be maintained beyond that session, which is in direct contrast to the temporary tables. Finally, there's permanent tables. These are similar to transient tables with the key difference that they do have a fail-safe period, which provides an additional level of data protection and recovery. Finally, on the left-hand side here, we have views. These are a result of a SQL query and can be viewed as if in a table. So if I click here and do preview data, you can see here a table at the bottom that has been generated by writing a SQL query. And if I click up here and do view SQL, you will also be able to see the SQL that was written to generate that view. So databases, tables, and schema can also be referred to as Snowflake objects. So now looking at transforming your data within Snowflake. Snowflake also has the capability to transform data and generate views within the server using ELT. As mentioned before, this can be done by writing SQL queries within the worksheets. So although this is quite a complicated SQL query, we're going to look at writing a slightly simpler one. So if I go onto this info table here, right click and do preview data, we can see what we have here is a list of books by ID 1 and 2 and their genre, and then some additional information here. So if I wanted to generate a table now, or a view of just the books with the genre young adult, I would need to write a SQL query, which can be done in here. So the first thing I'm going to write is select. And what you'll see is straight away it turns blue. This indicates that it's a SQL command. Select tells Snowflake what columns I want to bring forward into this new data preview. So I would like the genre, book ID 1, and book ID 2. Now I need to tell Snowflake where I want to get this data from. So the first thing to do is write another command, from, and I want to take it from this table down here. Now I could type it out, but there's also a faster way of doing this. So if I go back onto my table, click on these three little arrows and put place name in SQL, Snowflake will fill it in for me. Now I want to set my condition. So for doing this, I will use a where command, and it's where or when the genre equals young adult. And then I want to close this SQL query with a semicolon. Now if I run this, you'll see that in my results pane down here, I will see books that have only got the genre of young adult and then the book ID. This isn't actually a view, this is just a result pane. If I wanted to create a view, I would need to use the create view command. However, I can also download this data here as a CSV or TSV for my own personal use or to send on. Another great thing about Snowflake is how easy it is to load data from a variety of sources into your data warehouses. I'm now going to demonstrate how to upload a local CSV file into a Snowflake table. Although you can also use Alteryx and the Snowflake driver to upload data from a JSON, creating a live connection. So in this example, I'm going to be populating a table with data from a Makeover Monday dataset here. In order to create a table, we need to open a new worksheet and write another SQL query, much as we did before. I'm going to be writing this table into the data school database, as this is where I have permissions to write, and I'm going to select my schema as DS24. The first thing I'm going to do is tell Snowflake that I want it to create a table using the create table command. So I'm just going to write create table. And as we can see, this is turned blue because it is a command. I then need to specify where this table will be created. This can be done in much the same way as before by clicking on these three dots by the schema and clicking place name in SQL. So this here tells us the database and the schema. However, we are missing our table name. So I'm going to add another bit of text here. So there's going to be a dot, open quotations. And as this is a Makeover Monday dataset showing percentages of those who've never been married, I'm going to call this table Never Married MM for Makeover Monday. As spaces have their own role in SQL queries, I've separated the words with an underscore instead. This is a really good habit to get into in general. So now I need to bring in my column headers. These need to be in the same order and read the same way as those in my CSV. And I also need to specify the data type. So to do this, I'm going to open my bracket. And I'm going to start a new line. And I'm going to call the first one gender. And that's going to be a text. And then I need a comma afterwards. I'm then going to do age range. And I'm going to do the same thing as before. And have the underscore. And that is going to be a text as well, because although there are numbers in that column header, there is also characters. Okay, I'm going to do year, and that's going to be numeric. And then at last the percentages, so never married. And I'm going to do that as text as well, for the same reason as before. And then I'm just going to close my brackets, do a semicolon. So now if I run this, this should write a table to the schema. But I'm just going to put an error in here to show you the SQL error message. So when you do something wrong, you'll get something in the results. There'll be a little X and it will tell you the problem. So here it says unsupported type because I have got a typo. If I remove that and click run, there you have it. A tick here and table never married has been successfully created. Now that I've created my table, I'm going to go up to databases and I can see it's there, never married MM. So I'm going to click on that and I can see all of my headers and then a bit of information about the contents. Now I want to load this table in, so I'm going to click load table. I'm going to load it to the data school warehouse and I'm going to get my source file. So this is the CSV. So I'm going to select my files. And I'm going to click on never married and make sure it is the CSV because it won't work if you try and upload the Excel. Click open, click next, and I'm going to set the file format as CSV. I've already got this set up, but if you haven't, just click on the plus here and you're going to call it CSV. Select the correct schema, format type, leave these as automatic, and because you have headers in the CSV file, you're going to change that to 1, which is basically saying the first line of data or text in that file isn't a data value, and then leave the rest as default. Okay, I'm going to press cancel because I already have it. And then you're going to click next and just choose what you want to do if there were an error. So I'm going to put it as do not load any data and return an error. And then I'm going to click load. And now we can see never married, the CSV has been uploaded. Now I'm going to go back to my main page, look in my schema, and I can see I've now got a table called never married MM. And if I click on that and do preview data, you'll see that it's populated my column names and then the subsequent data from the CSV. This data can then be used to write SQL queries to transform it, or it can be uploaded into Tableau, which I will show you how to do now. Although we can create views and transform data within Snowflake, we can also connect to Snowflake via Tableau to create visualizations. To do this, we need to go into the connection pane on the left, and Snowflake is listed as a server. So as you can see, it's a recently used for me, so it's there. But if you just click on the More tab and find Snowflake within the list of servers, you can connect to it that way. Once you've done this, you'll get a pop-up like on screen, and you'll need to fill in your server details, which is the URL of your Snowflake site, minus the HTTPS prefix, your role, which is optional, and your authentication type. So as my Snowflake is linked to my Google account, I will choose sign in using OAuth, but you can also sign in using a username and password. So then clicking on sign in will bring in a pop-up like this, and then you do just need to sign back in with the details that you've specified on that pop-up. So here I can see the option to sign in with Google, so I'm going to click that, click on my Data School account, and allow access. Once I've done that, I will see a little message here saying Tableau created this window to authenticate. It's now safe to close it. So I'm going to do so. Now on my connections on the left, I can see the Snowflake address, my warehouses. So I'm going to choose the Data School warehouse, and also the option of databases. So I'm going to use the same database I did before, which is the demo database. And then you need to choose your schema. So again, I'm going to use the bookshop data. This will pull in all of the tables within that database and schema. These tables can be brought in much the same way you would a sheet on an Excel file, for example. So I'm going to bring in my book data and click to update it, and I will see all of the data within that table on Snowflake. Now this data can be used pretty much the same way as an Excel sheet, so I can also bring in multiple tables. So if I double click here and bring in award, I can create a join on that, click update, and now I will get the titles, the award names, the year one, and the book ID. Now this data is ready to visualize, so I can go onto a sheet and bring it in much the same way I would with any other data. And now if we go back to our data source, we can just have a look at the connection we have. So because Snowflake is a cloud database, this will automatically be brought in as a live connection. However, you can generate an extract. Remember, each connection or query will cost you money, and so sometimes it's more cost effective to build dashboards using an extract before switching back to live. You can also upload directly to a server using Snowflake, and that will maintain that live connection. So I could upload this to the Information Labs Tableau server page, and it would maintain that live connection. However, if you wanted to upload your data to Tableau Public, for example, you would need to use an extract. The aim of this video was to provide a brief overview and is by no means considered to be a comprehensive overview of Snowflake. In fact, I've only just scratched the surface when it comes to the available features and capabilities. If you would like to learn more about Snowflake, there are plenty of available resources. The first one is the Data School blog, which is a collection of short blogs written by data schoolers past and present, and I myself have written one on the content of this video. It can be found on our website up here underneath our blog tab, and if you are interested in solely Snowflake, if you just put Snowflake into the search bar there, you will get a collection of blog posts on various subjects relating to Snowflake. Snowflake also offers its own training schedule. However, this comes at quite an expensive cost. So if you're looking for more free resources, I would recommend also looking at the Information Lab's YouTube page, as it's a great place to find plenty of videos just like this one, and some more extensive and details from data scholars, but also some of the experts at the Info Lab. So this can be found on YouTube by searching the Information Lab or by this link up here, and you can see here a gallery of plenty of videos on various subjects. Again, if you're just interested in Snowflake, use the search bar and look for Snowflake. You'll find plenty of videos from some of the experts, as I said, and also some of the data scholars who are also still learning ourselves. All in all, just explore the resources available. There are plenty out there. But that's everything for me in this video. Please feel free to explore a little bit on the resources I mentioned before, and keep an eye on the til event page for more videos and webinars on Tableau, Alteryx, and the other software that we use.